all about 9.1, and we're using the rules of exponents now with the function notation. A little bit different than what you've seen before. So any problems with that? Any questions at 9.1?
Numbers 5, 7, and 11 and 13, please.
Anything else there?
Fourteen.
Anything else?
Nine, please.
Is that it? Anything else? Why did nobody ask 6? Because that's a common one that's all students mess up. Well, we'll start with number 5. So we're given the forms from 5 to from 1 through 5, where f of x is given to us as e to the 2x plus 1. And what we want to find for that is f of x plus h. So that's where wherever we have an x, we replace it with x plus h. So e to the 2, and for x, I'm replacing that with x plus h. I don't do the plus h separately. I do the plus h right here. And that's all it is. You could actually multiply it out if you wanted to, or leave it that way. F of x plus h is e to the 2x plus 2h plus 1, or leaving it like that. This is going to be useful in other contexts. That's all that is. Now, 6 was a little more complicated. That's a difference quotient. That's a calculation that you definitely do in calculus. But nobody asked that, so let's move on to number 7. This is a calculus calculation. So now you got to put everything together. So you take your f of x plus h minus f of x over h. So I'm going to show you the form that you're going to want to put it in when you get to calculus. So I just computed f of x plus h. So that's just equal to e to the 2x plus 2h plus 1 minus f of x. So that's e to the 2x plus 1 all over h. And what you end up doing in the calculus is you rewrite this exponential over here in this form. I can write that as e to the 2h times e to the 2x plus 1. So I pulled this out and wrote it as a product. Minus e to the 2x plus 1 over h. Now I see I have a common factor of e to the 2x plus 1, so I factor that out. E to the 2x plus 1. What do I have left? In this case, I have e to the 2h minus 1 over h. And essentially that's what you have there. And then that's the form that you want it in. And the calculus will take the limit as h goes to 0, and you'll do some fancy things to find out. You just found the derivative of that.
Excuse me, Professor.
Question?
So, yeah, when the e terms are next to each other and there's like no multiplication dot or parentheses, you're still treating it as such, right? Yeah. Okay, I just wanted to make sure.
Just like when I write that, that actually means 2 times x.
Okay, thank you.
You know, I don't write the multiplication. It's always there. That's just a number times another number. You just don't write it. In this case, common factor pulls out. And this is using the fact that e to the a plus b is equal to e to the a times e to the b. One of our rules of exponents. Okay. Then we look at number 7. Now we're looking at a different type of problem. This is just using the rules of exponents to evaluate some expressions. So 7, I have, you want to, given the functions below, simplify by combining using the rules of exponents. So I have f of x is equal to 2 to the 3x minus 1. And in fact, I'm gonna give myself some room. It's going to be a little bit cramped over here. Give it a little extra room. I don't get too cramped. X minus 1. The square root of 2 to the 4 minus 6x. Okay. The first thing I can do is I can actually simplify this. Just remember what the square root is. That's to the half power. So let me put in the extra step so you can see what I'm doing over here. 2 to the 3x minus 1. This is equivalent to 2 to the 4 minus 6x. The square root is equivalent to the 1/2 power. Then when I raise to a power, I multiply the exponents. 2 to the 4 minus 6x. This then becomes times 1/2 here. Okay, continuing on over here, 2 to the 3x minus 1. Distribute that, I get 2 to the 2 minus 3x. And these both the same base, so I can put them with the same exponents. So it's 2 to the 3x minus 1 plus 2 minus 3x. Then I can cancel. 3x minus 1 plus 2 gives me 2 to the 1 power, or just 2. This whole thing simplifies to the constant function f of x is equal to a constant of 2. And using those rules of exponents. But now, in a much more complicated setting than when you were first introduced them in Algebra 1 or intermediate algebra. Number 9. So f of x is equal to e times e to the 4x minus 1 times e to the minus x times e to the minus x squared. Okay, the first thing I might do is I might just get rid of, if you will, the exponent there. I'll combine some of these in a second, but I'm going to write what it is in a second too. 4x minus 1, e to the minus x, e to the minus x times 2. When I square it, I raise it to the second power. So what do I get over here? This is e. E is equivalent to e to the first power times e to the 4x minus 1 times e to the minus x times e to the minus 2x. These all have base e, so I can combine all the exponents simply by adding them. So I get 1 plus 4x minus 1 minus x minus 2x. Okay, right away 1 and minus 1 cancel out. And I get e, 4x minus x minus 2x. That's 4x minus 3x. This gives me 1x. So that whole thing just simplifies to e to the x. Even though it looks complicated, it simplifies to a very simple function. That one was a constant function. That one is just e to the x. That's just using the rules of exponents to achieve that. Number 10. Now this is the algebra manipulation skills you should be getting up to. Being able to do this without a lot of fanfare and difficulty. So 3 times e to the 1 minus x times e to the x times 3 to the x. All over 3 to the 1 minus x. Okay, what I'm going to do is just change the order over here and kind of manipulate things a little bit. So I get f of x. I'm going to put all the bases of 3 together. So that's 3 really to the first power times 3 to the x. Then I can put these together. E to the 1 minus x times e to the x all over 3 to the 1 minus x. Now let's combine some of the things over here. So like f of x, I can add the exponents over here. 3 to the 1 plus x, combining those, that's e to the 1 minus x plus x, and this is 3 to the 1 minus x. Well, these simplify a little bit here because the x and the minus x cancel out. But I can also now bring these up. I can change the sign of these exponents. I can write that as f of x is 3 to the 1 plus x. This can come up from the denominator as 3 to the minus 1 plus x. When it's underneath, comes up and changes. The 1 goes to minus 1, negative x goes to x, and over here I just have e to the first power left over. Put it down lower. Okay, now I can combine these over here. It's 3 to the 1 plus x minus 1 plus x times e. And I can cancel out the 1 and the minus 1 and add the x's together, so I get 3 to the 2x times e. Well, if I wanted to write that in a compact form, I could simply write it as follows. I could put the e first. E times 3 to the 2x. I could put the e behind it, but I don't have to. So that's what that simplifies to. Again, when you're dividing, you subtract the exponents. Okay, that's number 10. Number 11 over here. So given the functions below, rewrite using the rules of exponents in an expanded form without using negative exponents. We want to get rid of all negative exponents. So in these other ones, we started with expanded and then we contracted it down. Now we're going to start with a written in this form and see if we can expand it out. No negative exponents. So doing it both ways, expanding and in essence contracting. So 3 to the e to the 2 minus 3x. Okay, first thing I'm going to do is expand that up, break that apart. This is 3 times e squared times e to the negative 3x. Expand them out. Everything looks pretty good except I have a negative exponent. So what do? I make that positive simply by moving it underneath. Negative exponents come down as positive exponents. Now that's expanded out. There's nothing else I can do. Just write it that way. Now, this is good. I mean, if you want, you could actually expand it out further, but I'm not requiring it. You could write that as 3 times e times e times e to the x times e to the x times e to the x. Although this is definitely the preferred approach, but you could expand it out even further if you wanted to. But that is the preferred way to end up.
So, I just have a quick question. You can go first.
Oh, sorry. In the textbook, you had the answers like 3e squared times 1 over e to the x to the third power.
Yeah, you can write that as well too. That's just, writing it this way. It's the same thing. That's 3e squared times 1 over e to the 3x. That's equivalent to that. Because how do I multiply? Straight across from here to here. It's just factored out in e squared and wrote it that way to explicitly show what happened. You went from here to 1 over e to the 3x. An equivalent way of writing it, totally equivalent to that. So if you gave me any of those, or even if you gave me that, you'd be perfectly fine.
Just a quick question on, it actually wasn't on the homework, it was on one of the example problems, but for example, like one of the answers came out to be like either 2 to the negative 2x power or 1 over 2 to the positive 2x power, would those both be considered correct on a test since they're like the same?
Not by the instructions. By the instructions, if you read it, it says rewrite using the rules of exponents in expanded form without negative exponents.
Okay, so then you would have to keep it under like on the bottom.
Get rid of the negative exponent. This is the negative exponent, so I had to get rid of it and I turned it into a positive exponent.
Okay, thank you.
It's very explicit in terms of the form you want it in. I want to make sure you understand the meaning of a negative exponent. It actually means division. Another different sort of meaning of a negative number.
I just have one more question.
Mhm.
Would it also be correct to write 3e squared over e to the x, all raised to the third?
Yeah, you could also write it that way. You can just, write it either multiplying or 3e squared over e to the x, and then you could raise that to the third power. Yeah, it's fine. There's many different ways of actually recasting it, but that's fine. It accomplishes the main goal of getting rid of the negative exponent, so you can see what happens. Well, oftentimes we kind of like it in this form. It's a little easy to deal with. So you can see you're expanding and contracting. Now we're doing the expansion, whereas the other ones were the contracting. So here we have f of x is equal to 2 times 3 to the 1 minus x. And let's rewrite this by making and expanding that out. That's 2 times 3 to the first times 3 to the minus x. Well, that's just 2 times 3, so I can write that as 6 times 3 to the minus x. Well, negative exponent, I can write that as 6 times 1 over 3 to the positive x. So if I wanted to, I can write that as 6 over 3 to the x. Now, the 3 does not cancel into the 6 at all. There's no cancellation because this is the first power, that's the x power. So either one of these would be fine. But you need to understand that they do indeed give you equivalent expressions. So you need to be comfortable with those rules of exponents. That's 13. Hopefully you can see you're expanding them out or contracting them by manipulating, all through the function notation as well. So that's what we want you to do differently than you did in the algebra. So f of x is minus, take the negative of 2, e to the 2 minus 4x. Okay, negative 2 doesn't change. I'm going to expand that out, e to the 2 times e to the negative 4x. Only thing I need to do is change this exponent and make it into a positive, so it becomes negative 2e squared times 1 over e to the 4x. You can leave it like that, or if you wanted to, you could also simply write it as a negative 2e squared over e to the 4x.
Excuse me, Professor?
Yes.
I just have another unrelated quick question about dropping the negatives. So in one of the example problems, there was something like, I need to find it, but basically it's like if there is say there's 2e to the negative 2 power on the top, does the e always comes down with it and the 2 stays on top, right? Or do they all go together?
The exponent does not go with the 2. It would be different if you had this. This is 2 times e to the negative 2, which is 2 times 1 over e to the 2, as opposed to this. Say in essence, I had 2e to the negative 2. Well, that means both the 2 and the e are tied to that exponent, so that becomes 1 over 2e to the positive 2. See? It only takes the exponent, not the coefficient. And then I could write this as 1 over 2 squared, which is 4e squared. So there's different. If you have parentheses, you not only grab the base here, but you also, if the parentheses, they would grab the coefficient. Very common mistake for students to do that. And also, when this is negative, some students change the sign and bring that down to make it positive. Negative up front doesn't do it. A negative up top does, because then it's the reciprocal. Now, if you had 2 to the minus 1, e to the minus 2, well, that 2 to the minus 1 would come down as a 1. 2 over 2 to the positive 1, 1 over e to the positive 2, which I can write as 1 over 2 e squared.
So as long as there's multiplication in between them, you always treat them as separate terms.
The exponent only goes by, like, for example, 3 times 5 squared. I don't do 3 times 5 and square it and get 225. I do 3 times 5 squared, which is 25. I get 75. As opposed to some students, in their mind, they do this, which is incorrect. They get 15 squared and they get 225, which is the wrong answer. They're not the same.
Okay, thank you.
But it's meant to show that. That's how you understand how the rules of exponents work. And that's why I put a lot of these problems, because that's where students make mistakes. Because they don't quite understand the arithmetic involving these rules. And when you get to the calculus, if you don't get the algebra correct, your calculus problem is going to be way off. And you're not even going to get close to the correct answer. Okay, any other questions? Anything else in there? Looking at them now. But you're not sure. Anything else? Everyone think they know? Well, let me try and give you one over here. So try this one. And I want you to find this. You can find that difference quotient and manipulate it to get the h's and the x's separate from each other. Anyone want to see how I got that? That okay? We're all okay with that?
Can you please actually go through it?
Okay. This is our f of x. I want my f of x plus h. So everywhere I have an x over here, I'm replacing with the entire expression x plus h.
Oh, I got it now. Okay, thank you.
So this then becomes 2 to the minus 2x minus 2h. I get 2 to the minus 2x times 2 to the minus 2h. Plug that into this. So I get my f of x plus h minus f of x over h. So it's this first part over here. 2 to the minus 2x times 2 to the minus 2h minus my f of x minus 2 to the minus 2x over 8. Common factor of 2 to the minus 2x, so I can pull that out front, should I so desire. And I do, because you're going to want to work with that. And what do I leave behind over here? Well, I have a 2 to the minus 2h minus 1. Distribute that. I will come back all over h. Put all my h stuff over here, my x stuff over there. That's what you're going to learn to do in the calculus. And then you're going to do something called a limit process. That's the distinction between pre-calculus and calculus. It's the concept of the limit. And that's going to allow you to move along curves, move along functions, if you will. Okay, let's see if there's another one that can, if you can look at over here. So see if you can combine these. So combine as possible. Now here's my f of x. E to the 1 minus 3x times e to the 2 all over e. So see if you can shrink that down as much as possible. Make this e to the minus 1. Combine as possible. See how that works there? Anyone want to see how I did that? Okay. That's interesting. We can see that you do get the same function back. Let's just take a look at that in. Say we look at Desmos over here. Show you to get the same graph for both of those. So I'll take my f of x, and it's equal to a e to the 1 minus 3x. It's supposed to keep it up there. E to the 1. Nope, still doing that. Let me do it this way. 1 minus 3x, that'll get me up there. Okay. Bring it down, and I have e to the, make that 4x minus 2. Bring it down. And then divide all of that by e at minus 1. Now there's what it looks like. And if I look at the final function, I get f of x is equal to e to the x. Notice I get the same exact graph because they're equivalent to each other. Yep. Same exact functions. And that's what it's doing. It's showing you algebraically they are the same. Okay, so most people, I guess, are pretty good with this. Exponentials are a little bit easier than the next section, which are the logarithms. Logarithms are a little bit harder because their rules are a little more, they're actually related to the rules of exponents. They're corollaries, but they're, because of the inverse of the exponentials, inverse functions of them, they're a little bit more complicated. So let's try this one, and I want you to expand this out. Yeah, maybe it will. e to the 1 minus x over 2. So expand that out and write it without any negative exponents. And also, if you can, try and write it without fractions. Try and write it without any sort of fractions. See if you can take it to that level. That's a fraction now. That's another way of writing that. There's a couple ways of doing this, but we'll kind of see. If I want to write it without fractions, I could write it like that. With fractions, it would look like this. That's without fractions, using the fact that the square root is to the 1/2 power. So you should get, fairly proficient at manipulating exponential functions. Try some now with
Did you work that problem out?
yeah, so just rewrite this out. So this is -4 times, I break this down, e to the first times e to the minus x over 2. That's what it means when I break the e to the a minus b is e to the a, e to the minus b. Property of exponents in reverse. That's just e to the first is just e, so it's minus 4e. Negative exponents, I'm going to bring that down and make that a positive exponent. Then I'm going to factor out the 1/2 over here. So I can rewrite that as follows. I take my e to the x and raise that to the 1/2 power. It's undoing the, raising your power to a power. 1/2 is equivalent to the notation for a square root. Okay, that's the exponent form of the square root. And then I can just put it all under one expression over here. I can put it as -4e over square root of e to the x. So you should get proficient at manipulating these expressions. It will help you a lot. This is the things you should have been doing in the intermediate algebra course. Not so much with these exponentials and natural exponentials. You should see them a little bit, but not as much, I would imagine. Let's try another one, something that doesn't have that. Okay, what I want you to do is expand that out, use radical notation as appropriate, and no negative exponents. There's a couple of ways of writing. I just want to see as long as you do things appropriately. Putting in extra steps, I can see everything over here. It's just another way of writing it. That's an alternative way of writing that. Mixing the square root with the 1/2 power and taking the 3 out. So it's kind of manipulating this and writing that as x times 3 halves and breaking the 3 halves as 1/2 times 3. That is the square root of e to the 2x, and then that's cubed. Then you can also bring in inside, but I wrote it in terms of e to the 2x and radical notation. So that's the comfort level you should be trying to get yourself up to when you're working with the exponentials and rewriting them and recasting them. Because in the calculus, you will be asked to manipulate these things, putting them in a certain form so you can then start taking limits of things. And that's where things get kind of messy. Okay, any questions? Okay, so we'll let you go about 10 minutes early today. Tomorrow's a longer day. We have a couple of sections. It deals with one of the longer topics over here, which is the logarithms. So that's in our next section, properties of logarithms. That does take a little extra time. And we're also going to look at solving some exponential and logarithmic equations and see what is the strategy there, which is different than when you solve polynomial equations, which is different when you solve trig equations. Usually you're using the functions and their inverses. So exponentials and logarithms are typically involved when you're solving exponential and logarithmic equations. Sometimes you set them up so you have the same base and you just compare the exponents. So sometimes you have the same logarithms on both sides and you compare the arguments of the logarithm. But a lot of times you're using the inverse of these things to cancel each other out. So we're going to go back to what we did in the beginning part of this course, where we introduced logs and exponentials as inverse functions of each other. And I know it hasn't fully sunk in. That's why I like to do it again. And that's why I put it again in the textbook to come back later on. We're spiraling through and seeing it again in a different form. So hopefully you'll be able to master it better when you get up to the calculus. So any questions? Okay, so smile, wake up, everyone stay safe, stay healthy. We will see you all tomorrow.
Thank you, Professor.
Have a good one, everyone.
Have a good day.